Often when dealing with linear data sets, you're going to be asked to make a line of best fit for these data sets. One such method is to use your calculator and do what's called a linear regression. Okay, we're going to take a look at doing that right now. If you see here, I've got some data here about bottled water and soft drink consumption through the years 2000 to 2004. Both the questions here are very similar. There's three questions we'll address. Okay, the first one's find a linear equation that models the U.S. bottles water consumption, and the next one's find a linear equation that models the U.S. soft drink consumption. Again, over the years specified that we talked about from 2000 to 2004. Okay, and then down here it talks about use your calculator to predict the year that people will be consuming the same amount of bottled water as they do non-diet soft drinks. Okay, so the first thing we need to do is get this data entered into our calculator, and I'll do that in a sort of abbreviated way here. Real quickly, we go to Stat, Edit, and then in L1 I'm going to enter the years. In L2 I'm going to enter the bottled water data, and in L3 I'm going to enter the soft drink data. Okay, I'm just going to pause the video for a second so that you get the effect and I don't waste a lot of time entering data here. Okay, now as you can see I have all my data entered, which is just some crunching of the numbers to get it entered in the calculator. Okay, now what I'm going to do is make a graph of both these data sets. So I'm going to do a stat plot by doing second stat plot, and I'm going to turn stat plot 1 on. So I'll select 1, turn it on, and then I notice here I'm graphing L1 versus L2, so this is good. So I will do second graph, excuse me, I'll just do graph, and I will do zoom 9, which will zoom around my my lists that I've entered in, so it'll put that data in a better view. And then I'm going to go to second stat plot again, but choose number 2 for plot 2. I'm also going to turn that on. Now a little differently down here, I need to make a choice around what list I'm going to graph. I want to graph X versus Y, where X is the year, so that's still L1, but my next list I'm going to use is L3 instead of L2, so I'm going to do second and then the number 3, and then I'm going to hit graph. I'm going to hit zoom 9 again, so it'll zoom around both data sets now that both those graphs are active. And now I need to do a line of best fit for both of them. Okay, so that's some button work here that you need to follow along with. So what I'm going to do here is I'm going to do it for the bottled water data first, which is my L1, L2 data. So I'm going to hit Stat, right arrow for Calculate, number 4 for linear regression. Okay, you notice it's going to give me an equation of the form ax plus b, also known as mx plus b, so I'll get a linear equation from this calculation. Enter. Takes me back to my home window. Then I'm going to hit the second L1, comma, second L2. And that's enough to do the linear regression, but I also want to move this line over to my graphing window. So I have to follow that with comma, vars, right arrow for y vars, enter for function, and then where it says y1, I want to hit enter to select y1, which will put the linear regression equation in my calculator in my y1 window. So then I'm going to hit enter. Now this is enough information for me to answer question 16, which said find a linear equation that models the U.S. bottled water consumption. So I have my slope and I have my y-intercept, so I'll read it off the calculator and it'll say y equals 1.64x minus 3,600, excuse me, 3,000 263.32. And that is going to be my equation for that linear regression. And to do the other one, I just simply, again, I'm going to go stat, right arrow to calculate, select number 4. But now I've got to be careful, excuse me, what lists I enter. So I'm going to do second L1, because that's still my X values are in L1, comma, second 3 to choose L3 now, because they're my Y values in my L3 for the soft drink data. Then comma, again to move this answer over to my graphing window, we're going to hit vars, right arrow, function, and I'm going to select Y2 this time, which will put it in the second equation that I wish to graph. Okay? Then I'm going to hit enter there, and it's going to give me an answer for that one. It's going to give me an equation of a line, which is y equals negative 0.73x plus 1499.62. And that is my equation for my soft drink data. Okay, now when we look at the graph, if you see now, it's graphing the lines along with the data. Okay, it looks like the lines go right through the data. It doesn't. It's probably just very close. The correlation in this data is very strong, so it fits very easily or very closely with a line, but it's probably not perfect. You can tell that if I zoomed in on it. But where I really want to zoom now is over to the right, because this last question where it says, use your calculator to predict the year that people will be consuming the same amount of bottled water. So same amount of bottled water here is going to imply the point of intersection. Okay, so then it says also how many gallons per year will this be? Well, again, I need to look further to the right, so I'm going to go to my window, and I'll see that my X-max is going out to 2004. Well, let me take it out to about 2020 and get a look at it that way. Excuse me, that was my X-min. That should still be on 2020 for my X-max, which will look further to the right. And it does look like now I'm getting the intersection. So to find that intersection exactly, I'm going to go to second, trace, which brings up the calculate menu. And then I'm going to choose 5 for intersection. Once I get the cursor blinking near the intersection, which is great, it seemed to come up there naturally, hit enter 3 times. 1, 2, 3. And it says here the year is going to be 2009.67. I think that we could say 2009.6, excuse me, 0.7, which I guess would be 7/10 of the year through, so some amount of months through that's equivalent to 7/10. And the amount would seem that it's about 32.6 gallons of each being consumed. So that is, in a nutshell, how to do a linear regression on 2 data sets, as well as find the point of intersection, that is, if the lines in fact do intersect. So feel free to watch this again, play with your calculator. You have to get the button work down. It's a little bit of work, but then it becomes second nature.